explain how the stereochemical outcome of this transformation is consistent with SN2 type process. Just remember the SN2 reaction undergoes through the inversion of stereochemistry. Most of the time we've been dealing with the sp3, which had the Kahn-Ingold Prelog that show the system, right? The RNS. Over here, it's not going RNS. Instead, we are undergoing the cis and trans. Now, let's take a look at our compound 3. If you take a look at compound 3, or even compound 1 or compound 3, you're gonna, or even compound 2 actually. So all of them, you're gonna notice that there is the methyl group at bottom here, and then there's a methylene, which is quite analogous to methyl. It's like a CH3 here, and that's going to be CH2. It's not completely identical, but for now, let's just say, you know, they are pretty much the same. This is trans because you have opposite direction, right? But when you look at compound 4, notice that the methylene group, by forming the nitrogen forming a triangle here, we have a methylene group on that red mark I just drew, and then the methyl group is found here. When you have a structure that looks like that, that's just cis. It's on the same side, right? Just remember, this is not a cis though. This is not a cis because it's connected to the same carbon. It's a very common mistake. But since we have a different these substituents are connected to different carbons and they are on the same side, so this will be cis. So this still agrees with the SN2's stereochemical inversion. There's nothing exceptional about this. Therefore, I can just say this is trans that undergoes through cis. So this is typical inversion of SN2.